wanted you to make some observations about the things here. So of course, do that. Like, I mean, as it goes, you can see changes in them. So make sure you answer those and make actual observations. Try to be AP biology students when you do this and not just plugging in stuff to get answers. So then it was about this little Suchi disc thing or Secchi disc thing that you could see disappear, and you were supposed to measure when it disappeared. So that was the beginning part, and you had to pick a line, point on the container. I usually use the point on the container, this middle one, but you could use whichever line you wanted, which means all of our answers will be slightly different, and that's okay. All right. So then you just basically turned on your nutrient level. If you haven't done this yet, you pick 2, high, low, medium. I would pick high and low, honestly, and then you run them through each day and you see how much algae has grown. You can tell how much algae has grown because the little disc disappears whenever you can't see through the water anymore, because there's so much algae in it that you can't see through it. So that's what they're showing you here, the disc that's no longer visible. If you couldn't see these images, I can send you a link. I linked it in my in-person kids's. I linked it in modules for you guys. I can link it in my virtual kids's too if y'all need that. Okay, so then you just basically, when you can't see the disc anymore, you just measure, like you just see where that measurement is. And I usually use this middle one. But like I said, you can use whichever one you wanted. And I think they said use the level of the water. So on this question, you had to use like down here somewhere, like 66 or something. I don't know. Okay. So that was just kind of figuring out how to run the lab. And then they wanted you to do the trials. And so you just fill this table in like this. Okay. Basically, you just say day 1. The depth I could see was like, I don't know, 170. I mean, because you could basically see the whole thing. And then day 2, and then the depth I could see was still 170. And then meanwhile, it's calculating how many algae that would be the equivalent of at that time. And day 3, I don't know what it is. Maybe you could see to 160. Maybe you had some more growth that day. This one would be then your other population. So maybe this is low nutrient and this is high nutrient. And no, you do not have to add other columns and do the third. Okay, this is enough right here. So basically, you're just seeing what's going to happen here. So then day 1, just kidding, 170. 170, I don't know. I'm just going to plug in some numbers so that we can have a graph. That's kind of what I want to show you what to do on the graph. And then maybe you had 150, and then maybe you had some huge growth, and you had like, I don't know, 98, and then you had like 90, and then you had like 60. I'm just totally making stuff up. Do not put my data in. I don't know what your data are, but yours are probably way more accurate than mine. So I'm just going to throw some numbers in here so that there can be something that we can graph. And then this one was the low nutrients. So perhaps we didn't see as much growth as quickly. Okay. Let's go. Let's have some good growth on this one. Okay. So basically that's how you'd fill out the whole entire graph until you got through day 15. Okay. And that's what you would do there. All right. So then meanwhile, it's sitting here populating this down here, but this is not what I want it to graph. So here's how you change your graph. Is super important, because in the third module, you have to change the graph, or the third part, you have to change the graph over and over again. So time and days, but I don't want depth. I want population size. Okay. So I want population 1 and population 2. So now I can see growth. Okay. I didn't go long enough in my data to see it do this logistical thing, but what you should notice is you should have a curve, and then it should kind of taper off, and it'll go up and down around the carrying capacity. Like that's what you should see with that. Okay. So that's basically how you do that thing. So you just sit there and enter data until you have it all entered. And then you should see a logistical curve on that, because it should show you an like exponential increase, and then it should level off. Okay. And then definition of carrying capacity, make sure you can do that. And then what could be, of course, your nutrients. Amount of space could, I don't know. So things like that. We're not changing the temperature and the weather or some consumer thing, but I mean, I suppose seen here. No, we're not changing any of that. So, okay. So then you're going to calculate the average growth rate. So basically you take a 3-day period with the greatest growth. So you go back up to here, and or you can look at your graph too. You could be like, ooh, there's 1, 2, 3. Like, oh, that was a 3-day growth period right there. Look at how much it grew. And you subtract the 3rd day. You take the 3rd day number and you subtract the 1st day from it. So whatever it was, okay? And then you divide it by 2 basically, because you do then 7 minus 5 because those were your days. So you divide how many algae, take your highest number and then subtract the lowest number from it and then divide it by the number of days, okay? And that'll give you your growth rate, okay? And then you're going to estimate your carrying capacity. That's pretty easy to do. You're going to see where that levels off. Here, I can show answers and notes and show. I can show their graph. Okay, so see where it levels off right here. Then you can sort of estimate, well, for population 1, and I don't know which ones they did. This is just a sample one, so yours might be different. Population 1, it looks like you could carry, you know, somewhere right in this range right here. So I can just kind of say maybe 1.3 million cells. It might have been a little bit high. So, but you can just, I just want you to estimate. So you just estimate where it could level off. But like, see up here, oh, get out of the way. On every time I do this, it's going to put a line on there. On day 11, that was a little bit high for our little green box there. Okay, so that one was a little bit high. So it couldn't really support day 11 for the boxes, population, what is that, 2? Population 2 at the top here, it couldn't really support that 2.23 million cells because it had to drop back down. So you kind of want to estimate somewhere where it could support it and didn't overshoot it. Okay, so then you just estimate what that is there. Okay. Where were we? We were estimating our growth rate. So what was I doing? I totally forgot where I was. Estimate the carrying capacity. There we are. So they did all 3 of them approximately. And then, of course, it depends on yours. If yours are not those answers, that's okay because it's based on your data. And so don't try to just make up answers or put theirs in because yours look wrong. This whole entire thing is based on your data. So basically then what we're going to do here, I'm going to turn off the answers. So you're going to, you calculate the average growth. We did that for the 3-day period after the population reaches the point you identified. So it's the same thing, except you want to calculate your growth after you've reached carrying capacity. So remember how we had a nice little graph here. Pop the graph back on, Miss Wilhoit. After we had, so like, what's the growth rate here? They want to know like the 3 days after it reached carrying capacity, not in this high growth period here, but after it reached it. And it should be somewhere near 0. Like you shouldn't see a lot of growth after it hits carrying capacity. Okay, any questions about that? Those concepts. It's the concepts I want you to get. Okay, it's like, how much growth did you see after it reaches carrying capacity? Not much, because you've reached the limit of your nutrients and stuff. And so you can't just, you know, keep going. So you should not see much. How much growth should you see whenever it's in the most period? Oh, you should see a lot, but definitely there's going to be a difference when you're looking at a logistical curve on your growth rates. Okay. Some of you guys need to make sure that you understand that whenever you're looking at a graph, the highest growth rate is when your slope is the most steep, right? And so when it talks about like, what was the, you know, during the highest growth rate period, you know, what was the growth? Well, you'd have to, like, some of you guys, whenever we had one of these practice questions, I don't remember which test it was on or whatever, you wanted to do it like at the highest population. Okay, that's not the highest growth. Make sure you know that. I'm going to pop this back on again. So our highest growth is right in this area, wherever you're seeing this big slope right here. That's the highest growth. This is like no growth. This is like just chilling. It's your highest population, but it's not the highest growth. Are we good with that concept? Anybody have questions about that? Because that was something that kind of confused quite a few people on one of our other tests. I don't remember which one it was. Okay. So we got that done. Okay. I need to remember what number I'm on because then I have to sit here and read all these. Okay. Using the information from the previous question, explain the biological factors that determine the shape of the growth. So, and for both populations you studied. So we want to know like why one of the slopes was lower than the other one, kind of thing. Just talk about that. Biological factors that determine the shape of the growth pattern. So how come one of them had a steeper growth than the other one, kind of thing. It's going to be based on your nutrients. What's going to happen if you keep it up for 16 days? And tell me why. You can do those. If each algae population is given additional nutrients, what's going to happen? Okay, so I do want you to think about those and answer those with your brain. Okay, I don't want to answer those for you. Does anyone have any questions about them? That's not what is the answer? All right. Okay, so now the hard part. This is the part that I'm saying we're going to do like the best we can without like sitting here and like stressing over every nuance of these formulas, because what will be given on the AP test, if we will be given the values, okay, because they're not going to make you calculate values on a lot of this. They might ask you to estimate carrying capacity. That's easy to do. So whenever it gets into like calculating R max and all that stuff, they will give us R max, or they'll at least give us the per capita birth and death rate, so that we can just subtract it and get our max. So it's not like this is harder than what we have to do in real life. So I'm not going to sweat it. Okay. So they just want you to look at these two formulas, and this is good for you, and tell us what the heck, like what's the difference between them. And so you have to look at these. Exponential formula is limited by R max, while logistic formula is not. Okay, so here's the exponential formula right here inside the logistic formula. So there's got to be something different between them. Okay, so it's going to have to be something about this chunk. So just figure that one out. I think you can. If you can't, let me know. Consider the exponential growth equation. And this is just algebra. Like, what do you do to isolate R max? So you're going to have to, to get R max by itself, what do you have to do? Basically divide this thing by R max. Okay, that's just algebra. What happens to the Kn term as the population N grows towards carrying capacity? It should be getting closer to 0, because you're going to see no growth. Remember, this thing right here stands for like growth, right? Or rate of change, the rate of growth. So if you're getting this closer to if you're getting closer to your carrying capacity, this should be getting closer to no growth, because it's just being smaller, 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 smaller. Okay. That's just because it's a logistic equation. My neighbors are being noisy. Just make sure that I don't have anything on the chat. Sorry. There we go. Okay. Yeah, ask questions if you have them. So let's see. Where was I? Okay. Still in the logistic formula. What will happen to the D and dt? So what will happen to the growth rate as the population N moves towards K? It's going to decrease to 0. Same question. I don't know what was up with that. Okay, so now you have to take, so there's a couple different ways you can do this, but basically you have to take your data from before. I would take my data from before. I wouldn't be like using new data. I wouldn't use the third population. I would use data from before, probably my high nutrient or whatever you want to do. And you're going to put it in here, okay? You can just put them side by side and type it in. I haven't tried to copy and paste it in. I know that if you click on this little thing, you can download it as a like a Google Sheets thing. But whatever, it might just be easiest to just like populate it with your depth. So I'm going to go ahead and I'm going to show you what they got. Don't think that you need to get the same thing. Remember, it's your data. And I don't even know. I think they're doing high nutrients or something. I'm not sure. So they basically just reinserted this column right here. Okay. And then they subtracted, and I'm not going to lie. I can't get the numbers they're getting. So I redid all of this with my own numbers, but let me show you. I think they did it based on the slope of the line, and they calculated slope for each point, and I'm not about that life. So I just took these 3 dots right here, this population size. You might want to watch this because it might make your life easier, unless you love these scientific notation that you can't see what that E plus is. I don't even know. I take this and I'm going to say, I want to change my settings here. I want to take this out of scientific notation, and I'm going to put it in just some decimal places that are shorter, because I'm going to shorten this crap, and I'm going to say done with that. Okay. Now I can like sort of tell what the heck is going on, because before the numbers were so long that they were going off the page and doing all kinds of weird stuff. So once again, I just took this and I changed my column settings and told it I just wanted it. And I could even say, I don't want decimal places. Like, this is how not caring about the like nuances of the formula I am. I'm like, make it as easy as possible. And so then you're trying to figure out how much it grew. This is where I'm like, this is not 78,000. Like, I don't know what they're doing here. So basically I just, in the end, ended up ignoring their data and ignoring their calculations and doing my own. So basically I'm like, okay, so if I had 266,925 algae, whatever, and now I have 401,000, like, what was the growth there? And I put that number there. And I did the whole entire column. It took me like, I don't know, 5 minutes. I just had a calculator and I just subtracted that from that, put it in there, subtracted that from that, put it in there. I only got 2 of the same values they got. So I don't know what the heck they were doing. Because I mean, clearly to me, this is not 0, but it's very close, but it's not 0. So anyway, so I did that, and that gave me a lovely little, well, first of all, per capita growth rate right here. This is going to be your R, honestly. This is your R, only it's very difficult for us to calculate R max with a whole entire logistic data data curve. And so I'll show you which one I picked later and why. Actually, I kind of got an average of them and why. Okay, so this is our graph. So you have to do some changing of the graph. Like, so after you put all of this in, all of these numbers in, and you calculate that. So this is probably this right here is probably going to take you about 10 minutes, maybe 15 if you are just taking your time. Okay. But it's just subtraction. After you enter your data from the table above, it's just subtraction. Okay. And so, but then it asks you to do a lot of different things with this graph. And so there's 3 different ways you're going to graph this. So let's make sure we know how to use the graph. That's the first thing. So, okay. The first one, I'm going to leave their notes on and everything. The first one, you're trying to graph population size versus time. Okay. So time is going to go here. All right. And population size is going to go here. So you see how I'm changing the graph. Okay. I don't want a curve on it. So I'm going to a line on it. So I'm going to take this little curve fit and I'm going to say none. Okay. So now I have a logistical growth curve. Okay. But I had to do what they said to do. And I had to take that stupid line off. Otherwise it looked like it was trying to get some sort of like slope or something. Okay. So that's how I did that one first. And then I can answer the questions about that particular graph, but I have to do what it says to do. Cause right here, it tells me how to graph it. Okay. To get that. All right. So, and then it asked me to estimate carrying capacity, which should be somewhere around, I don't know, maybe 2 point something million, just right above 2 million. Cause then it gets too high. It has to drop back down again. So but this is on my data. Or actually their data. I didn't do all this. So don't fret if yours is lower or whatever, because you may not have used the same nutrients they did or got the same measurements they did. And that's okay. It's your data. Okay. So basically then you go down, and I'm leaving the answers on, but that's just because I can't, here, I'll take them off on these multiple choice ones. So basically you're going to go through and it's going to say, now graph the data to show population growth versus population size. Okay, so now we're going to go back up here and we're going to say population size and population growth. What did I just do? Oh, I know what I just did. I took off their thing. Population size, okay, and population growth. There, it's on there already, okay? So, but if it wasn't, then I would take it and oh wait, population growth, not per capita growth. Okay, population growth, population size. That's what I got. Okay, so then I'm going to zippity dippity down here. And it says, fit the square law, fit to the data. What does that mean? That means go up here and say curve fit, square law. Just do what it says to do. And then you can follow like what the actual answers are. Let's see if that worked. Fit the square law, fit to the data. The population follows our exponential model. Oh, at what point will we expect population growth to be 0? Okay, so now it's saying, look, it's doing an exponential growth. Wow. When would we ever expect the population? Well, at 0, right? Because that's the only time it's ever going to be 0 if it's doing exponential. Okay, that's fair. All right. So consider your graph that shows population growth versus population size and your answers to the above 2 questions. Oh, you have to go answer those questions too. Let me see. Oh, wait. Oh, never mind. I totally skipped on. I told you I need to figure out what number I'm on so I can stop doing this. Now graph the data, population growth versus population size. Okay, so just do that and then fit a quadratic fit. And it's going to give you like the quadratic looking graph. Like a arc. So then, and then it asks you what 2 points would we expect our value to be 0? Well, you just look at it and say, okay, I don't think it's going to grow at this point. population 0. And I don't think you're going to see growth when you hit equal carrying capacity, because then remember, no growth once you hit carrying capacity, because it's no more growth, or else things die. Okay, so then it says it wants you to go back and revisit, or this is the one we just did, population growth versus population size, and your answers to the above 2 questions, and then just describe some evidence from the graph that supports using an exponential model or a logistic model to describe this population. Okay, so it's going to be a logistic model. Spoiler alert. But then you have to tell why, and you have to tell what the carrying capacity would be. All right, now you're going to graph showing. So you're just changing your graph over and over again, and then fit a linear curve in. This is kind of where it's getting a little bit more iffy on how much of this we actually need to do. Whoops, I selected an answer. I didn't read it. So remember that to calculate per capita growth, we need to take the growth rate and divide by the population size. So that's how you would do that. Okay. I mean, that's okay. We can do that. And then consider your graph that shows per capita population growth. So this is the graph you're using right here, and your answers to the above question, and describe evidence that supports exponential or logistic, and identify the Rmax value from your data. So you're going to do the Rmax value from the data. Basically what I did on that, it says that you're supposed to do like your per capita growth rate. But basically what I did, I'm just not even going to lie to you here. I just did it the easy way. I mean, I think it's the easy way. Let's get some data back in here. Okay, so what I did was I found my carrying capacity, which is about right here. This is the closest to carrying capacity right here. And by the way, this shouldn't be 0. I don't know why it's 0. It should have a number in there too. But I found my carrying capacity, and I found what the growth rate was when it hit carrying capacity. So from there to there, and I just used that for my maximum growth rate. Is that the right way to do it? Probably not, but I'm not an ecologist, and what you're supposed to do is figure out the maximum growth rate it can do. So you can, if you want, do all this and, divide it by the population size and do all that, but it's going to come out to be right around when you hit carrying capacity what the growth rate was. So I just used 0.06, and I think they used 0.07. So I felt like I was pretty close to that. But so when we hit carrying capacity, so you look for carrying capacity, you do that, whatever the growth rate was on that date to come to that is approximately your maximum, because that's kind of when it was up that high slope, and it's like can't grow any faster than that, or else you'll run into things. And an ecologist would say, I call bunk on that, Miss Wilhoit. You have to actually calculate it. And I'll be like, not in AP Bio. So I would just pick the maximum, the growth rate at when it hit carrying capacity as your Rmax. Now on the actual test, they would give you like the 2 numbers to subtract to get that Rmax. Okay. But regardless, it's that either way you want to do it is fine. You can do it the way that they did it, which is like calculate per capita growth. We take the growth rate and divide it by the population size. But when you have all this many points, it's like, okay, that's going to take me literally forever. So and you can also average all their growth rates, and it'll get pretty close too. But I didn't have time for that. I mean, you can actually download the data and average it in a spreadsheet, but I really am not that interested in you calculating maximum growth rate, because we don't have to do that for this class. So consider your graph that shows the per capita population growth. And then so you finish, oops, hide the answers. So then you finish up basically this whole entire thing. There's just a couple questions here by basically, hang on a second. I got to remember which question this is. I just went over this. Why is my memory not working? Okay. So then you're just saying exponential or logistic. Tell me why. Identify the Rmax from the data. I'm going to say whatever your carrying capacity Rmax growth rate was, that's going to be your Rmax. If you choose logistic and identify the carrying capacity, cool, we can do that. Just where did it level off? And then you're going to, on this particular part, based on your analysis of the data above, which formula would you use? Okay. And then you're going to create an equation. So you're going to use the logistic growth formula. Once again, spoiler alert, you're going to use the logistic growth formula because it, leveled off. And so you can leave the ends in. You don't have to have a population size. That's not part of it. So it says include numeric values for Rmax and for K. Choose the Rmax that you want. You can average all the growth rates. You can do the birth minus death divided by population size if you want to. I would just pick the growth rate at carrying capacity, but it's going to be a decimal, okay? Like 0.06 or something. And then K is just your carrying capacity. And there were it says you should have 3 K values. You can average them. They should all be really close together because within this little third part, we had to find K 3 different times, like, but they're all should be very similar, somewhere around 2 million if you're doing the high nutrients. Okay. And so then you just write out a little formula right here that's like R max. So that'd be like in parentheses, you'd put like point, whatever you choose for yours. And then you'd say N. You don't have to have a population size. Then you do your little parentheses and do your K, which is whatever your carrying capacity is, minus N. Don't have to have population size, just write N divided by a K again, whatever that value is. So it wants you to just have numeric values for R max and for K. And that's the only two that it cares about. Okay. It does take a while. This section 3 does take a while. It's not going to be a super fast kind of thing. Hopefully, my kids in class yesterday, you got 1 and 2 knocked out so that you can just work on 3 today. Some of you got to 3, I saw. But anyway, so that's a kind of a lot. I do want you to not sweat the math of it. I want you to know that in AP Bio, they will give you the math to do. So you don't have to sit there and go, oh my gosh, I don't know what I'm doing, how to calculate the R max from a data table. No, we don't have to do that. That's why you don't know how to do it. If you needed to know it, I would have taught it to you, but I don't even really know how to do it from a big data table like that. Like it's not anything I've ever had to do. So you don't either. So just find the highest growth rate when it went into carrying capacity. Okay. Not on the slope. If you're on the huge slope, the exponential portion, then that's not the growth rate we want. That would be growth rate for like an exponential growth. But if you are applying that growth rate to a logistic model, you're going to overshoot your carrying capacity. So that is not, so when it says maximum growth rate, it's not talking about like the maximum it ever was. It's talking about the maximum growth rate that it can sustain at carrying capacity. And that's why I pick that growth rate right when it hits carrying capacity. But yeah, you can calculate it the long way if you want to try. I'm all for it if you want to try it, but most of you don't have time for that. I don't. Okay.